Hello everyone, welcome to day 3 of HAR. Hope everyone's having a good time. Our next presenter is Neil Tursing. He's going to be presenting on how to break into Windows domains. So without further ado, here he is.
It is on? Oh, great. Thank you. Good afternoon, everyone. Welcome to my talk. Sorry about that. I hate technology. Okay, there it is. Good afternoon, welcome to my talk, how we break into domains, what every admin should know about Windows security. Before we get started, I'll tell you a little bit about myself. My name is Niels Tursing. I work for a Dutch IT security company called Fox IT, located in Delft. I do pen testing, all sorts of pen testing, web applications, networks, social engineering, you name it. Been with them since 2005. I was at the 2 previous events in 2001 at HAR, at What the Heck in 2005, and I'm glad I can contribute to the talk this year. So what's this talk all about? Well, we do a lot of internal pen testing, so we see a lot of internal networks, and we see what usually goes wrong and what goes right, but this talk should mostly reflect what goes wrong. It's not really about how to break in domains, not how to do it, although if you want to do it, it should help you a bit, but more about the techniques and how they're combined. It's not intended as an anti-Microsoft rant or anything, because, well, we break plenty of Unix systems as well, usually. So, a bit of an outline. First I'll talk a bit about getting into a network. How likely is it these days that an attacker would actually make their way into your internal network? Then a bit about getting a foothold in a network, compromising those first couple of machines, so you can go on from there. And finally, about expanding influence into a network, maybe taking over large parts of the network, perhaps even the entire network. And that's also where a bit of my own research comes into play. So, getting in. Well, there are too many ways to fit on a slide to do this, so I've listed a couple. May not be so obvious, but physical access is a very effective one. As I mentioned, I do social engineering things as well, and you'd be surprised how easy it is to just walk into buildings if you look nice and don't wear shorts, but a nice suit. And well, you just plug in your laptop and pretend like you belong there, and well, if they have badges, people don't usually check for them. So that's pretty effective, but of course, it's a bit cumbersome going to all those companies. Client applications, of course, you've probably heard about these in the news. All the PDF exploits, Flash exploits, Internet Explorer, Firefox. And it's very popular to exploit these nowadays. And funny thing is, I mentioned I was at HAL in 2001, and one of the presenters actually had a talk about exploiting client applications. I totally forgot his name, and I can't find it in the schedule anymore, but he had written some kind of Internet Explorer exploit, and he asked the whole room full of security-conscious people who has ever patched their browser. This was in 2001, and only 2 people raised their hands. So things have really changed a lot since then, and it shows that these conferences really are useful. Server applications are a bit harder to attack on the outside these days because everybody has patched them or has been forced to patch them, because if you have a vulnerable server on the outside, then a worm will probably get it. And all you need to do is send someone a malicious PDF, direct target. Also in the news, some guy was targeting CEOs of companies, so he was sending them PDFs with some sort of exploit in them, and when they double-clicked on it, they would take over their PC. Or it may even be random attacks. There are plenty of websites out there being compromised and malware being put on them. You end up in some guy's botnet, and you could probably check once in a while if he's infected some interesting clients, and well, he can explore the network if the PC is in a corporate network. Web applications is something I also wanted to mention. Well, as I said, vulnerable server applications are pretty rare, but there are still a lot of web applications out there with a lot of custom code, and well, they're usually on the outside of a network and they're connected somehow to the inside of the network usually. So I've used that a couple of times to actually get into domains from all the way from the outside. They can be very helpful. So it's quite likely these days that an attacker would somehow make their way into your network. So now what? Most attackers would go for low-hanging fruit, those easy-to-compromise targets. And when I'm talking about low-hanging fruits, I'm talking empty passwords, easy-to-guess passwords, default passwords. There's always a couple of those on the network. And usually when you scan a large network, you'll find, for example, a couple of workstations that have some SQL Server or the mini version of the Microsoft SQL Server on there with an empty or easy-to-guess password because they've installed some Office application that requires them to have a SQL Server. And, well, you may say, well, who cares about those SQL servers? There's probably not a lot of interesting information on there, and it's only one user. But, for example, in SQL Server, you can execute a stored procedure which allows you to execute commands. So it's a pretty convenient way to take over a PC, and there are usually a couple of those out there. And other database servers as well. Missing patches is quite an obvious one. We obviously still see those a lot. These are some of the usual suspects from Microsoft. And the latest one, MS-08067, is the last one in the line of remote code execution without authentication on SMB or RPC ports. So you just talk to some default Microsoft port on a system that has those open, and you can execute codes unless they've installed a patch. That patch was released in October last year, I think. Microsoft suddenly announced they were going to release a patch, and they weren't even going to wait until next patch Tuesday because people were already exploiting it and writing worms for it. And it's also the one that Configure exploits, so we know how popular that is. But even if the patch management of Windows systems is all okay and everything's patched nicely, usually you find third-party applications, and these are also some of the usual suspects. Trend microservice attack, for example, backup exec. If you haven't patched these and they listen on some high port on your server, and some guy has figured out that they're somehow vulnerable, and you can toss code at them and get remote code execution as well. And these are a bit harder to patch because they don't come with your standard Windows updates, and you have to actually know what's on your servers, and that tends to be a problem at some companies. Sometimes you have to go to a bit more trouble, but there's always some little thing. For example, Cisco announced a couple of months back now, I think, that there was a directory traversal in one of their TFTP servers, the one that comes with Cisco Works. And I decided to take a look at this, how hard or how easy is it to trigger this bug. And it turns out to be pretty easy. You just put ... backslash ... backslash, and you can traverse directories all the way to the system root and grab the bootpen.ini or something. And you can read files, and you can't create new files, but you can overwrite files. And the TFTP server runs a system, so the high privilege user. So I decided to look for an interesting file to overwrite or to get. So to get basically instant compromise. And it turns out Cisco Works also comes with an Apache server, which also happens to run a system. And most of the Apache server is password protected, but there are some CGIs you can access without having to enter a password. And 404.pl is one of those, an error CGI. And you can simply override them with a directory traversal exploit and override that CGI, and then visit the target from your web browser, execute the CGI, and you're executing code as system. And well, you can imagine what you can do then: add users, Metasploit payloads, anything you want. And it's basically a miracle that they released the the patch only now. It has been in there for years, and even when you toss a Nessus scan at that system, it'll find it. So once you're on a couple of systems, or maybe even one, what I like to do is steal the keys. And when I'm talking keys, I mean passwords. Usually plenty of passwords on systems you compromise. For example, a lot of companies still install VNC on workstations for some reason, and usually share the password between systems, and VNC password is usually easy to find, easy to crack, and you can do lots of fun stuff with that, or some other remote administration tools. If you compromise a development database server, for example, which are usually not that well protected, some Oracle system or something, you often find passwords that work on other systems, on production database servers, for example. So it's a nice way to go from development systems to production systems. One thing you'll always find is local administrator passwords on Windows system. And the local administrator password, local administrator account is hardly ever disabled. And why do I think these are evil? Well, I think in about 90% of all networks, those passwords are shared between machines, at least some machines, which is somewhat logical because in large networks you don't go around with CDs to every machine and install Windows and click next and next. You create an image and you deploy it to all those systems. And that local administrator password is often shared. So when you compromise the one machine, the one workstation, you crack that local password, and it turns out you can log into the next system, and the next one, and the next one, and the next one. And if you're really lucky, it will also work on servers, so compromise one workstation and get into a server. If you're really, really lucky, and I've been really, really lucky, it also works on the domain administrator. So don't do that. So how easy is it to crack these passwords? Most systems have the backwards compatible format enabled, the LM hash. And this is an easy to crack format. It's enabled by default up to and including Windows 2003. Vista doesn't store it anymore by default. Windows 2008 doesn't as well. Windows 7 probably doesn't do it as well. And it's for good reason. You don't really need this anymore. It's for communicating with legacy systems. And with legacy, I mean Windows 98 and early NT4 versions, things like that. Well, to compare on how easy it is to crack the old format, the LM format, and the NTLM passwords. With an LM password, you can crack a password up to 14 characters, and basically with everything that's on a keyboard, and that's reasonable. And there are now remote tables with even some strange characters in them. They've been recently released, and a colleague of mine, Daniel, worked on those. But basically, you can crack, dare I say, every, now not Chinese, for example, but most LM passwords you will easily crack, because 14 characters is also the maximum, so if someone has a longer password, the LM hash will not be stored. But if you find only an NTLM hash, 8 characters is where rainbow tables exist in not a really large character set, mixed alpha space. If you want to crack a 9-character password, you basically allow limited to alpha space, and 12 characters if it's just numeric, but how often does that happen? So if NTLM is enabled, it's harder to crack those passwords, unless of course they're using dictionary words or something, but brute forcing them is hard. But luckily there was a guy in 1997 that came up with a technique to circumvent cracking the password. What Windows basically does is when you authenticate to some share and you type your password, it hashes the password on your computer and uses that to authenticate to the share. So it uses the password hash to authenticate. So if you have those password hashes, they're basically password equivalents, at least in the case where you're enabled to SMB and shares. So there are public tools out there. There were public tools out there in 1997 to do this. If you just have the password hash, you don't need to crack the password, but you can just use the hash to authenticate. Doesn't work in all cases. If you want to RDP, a remote desktop to a system, you'll still need the plain text password. So you'll still need to crack it down. But yeah, really powerful technique, and already in 1997. Wow. And I wouldn't be surprised if worms actually started using this. That when you get a worm on your system and it looks at local administrator passwords, maybe tries to crack them, and if it can't crack them, just pass the hash along to other systems near it, and well, I think this could cause major problems on a lot of networks. Also a nice technique is token stealing. Luke Jennings implemented this in 2007, presented it at CCC. And what this basically is you've compromised a couple of machines, you're administrator on them, maybe a couple of workstations, you elevated your privilege to other workstations because there were some shared passwords, and you start looking at who's logged on to those workstations. And are there interesting people there? And an obvious interesting person is a domain administrator. So say you compromise a server where a domain administrator is logged in, or even a workstation where he just is working at, or he doesn't even have to be at the console. He left the session open, and you've compromised the machine. So what Luke Jennings' tool does, Incognito, is it looks at who's logged in and looks at their access tokens, which is basically a way for Windows, a token which you can use to authenticate to other systems. And Windows basically has this in memory, and it's basically sort of your hashes cached in memory. And if you're a local system or administrator on that machine, you can take over those sessions of those users. So if you take over a session of a domain administrator, suddenly you are the domain administrator. If he's logged on to that machine, you can execute commands on his behalf and add users to the domain, things like that. Of course, you could also install keyloggers and do it that way, but this is a lot more convenient and really instant. You can even automate this. So he has a really nice paper. I'll list it at my blog at the references, and if you're interested in this, it's a good paper to read. So, if you've managed to do that, and you're on the domain controller, and obviously there are a lot of different paths that can lead up to this situation, but this is usually an easy one to use, and it usually works in most networks. What you can do now is harvest even more passwords, and make your way into other connected domains, for example, of neighboring companies, try to crack passwords and use those to get into Unix systems, maybe network components, things like that. But sometimes you don't even have to crack those passwords. I'm not sure if you can read the last part with the checkbox, but it says store passwords using reversible encryption. And this is something that Windows actually allows you to do. What it does, if you tick that box, and you can tick it for a single user or even for the entire domain. And if you tick that box, Windows stores the hashes for that user, the NTLM hash and the LM hash if that's still enabled. But it will also store the password in an encrypted form, but in a way that it can reverse that encryption. So it's not enabled by default, but you can enable it by just ticking a box. And you may wonder why. Why would anybody in their right mind ever want to recover those plain text passwords? Why would you ever need them? There are actually a couple of authentication protocols that require you to have the plain text password in order to confirm that the user has the correct password. An example of that is HTTP digest authentication. You can enable this on IIS servers, for example. Ticks the box. I want this directory to be protected not by basic authentication or NTLM authentication. I want digest authentication, because I think that if you think you need crypto or something, because it does some crypto, and you don't have SSL, for example. But Windows will tell you, hey, you can do this, but I'll need to store the passwords using reversible encryption. Another example is CHAP. If you have a VPN, for example, or even dial-up, and you do CHAP authentication, Windows also needs the plain text password to authenticate that user. And how that works is basically Client tells the server, hey server, I'm Bill, I want to authenticate to you, I want to give you my password so you can confirm my identity. Server says, okay, no problem, but I don't want you sending your plain text password because people might intercept it. I also don't want you sending a hash of your password because, well, people might intercept that and use that to authenticate. So we're going to do a little challenge response thing. The server sends a challenge, which is basically a big random number to the client, and the client takes that random number, adds his password to it, hashes that whole thing, and sends it back to the server. So, in order for the server to confirm that that user has the correct password, he needs to recreate that hash and compare it to the hash he has just received. So he needs the challenge to create that hash and the plaintext password. So this is one of those situations where you need the plaintext password. And this is a bit of oversimplified diagram, but you get the point. And this is not MS Chap, by the way, or MS Chap v2. This is regular Chap. With MS Chap, you don't need to store the plaintext password. So when I first heard about it, I thought, well, who cares? Nobody uses this. Who would enable this on their domain? Why would you use Chap? Why would you use Digester? There are other things out there that are just as good or better. But then you start seeing it in the wild. People actually use this. They enabled it for a couple of users because maybe they checked the box accidentally or something, or for the entire domain you see it sometimes as well. So I decided to do a little research, a bit of reverse engineering, looking at those binaries involved and seeing if I could figure out how does this thing work and where are those passwords actually stored and does it create any additional risks. So I started looking at this process, and I enabled it on a testing domain and started looking what processes are involved and what DLLs are involved. And I came up with this one, it's res-sfm.dll. And this is a password filter. And what password filters are is there are a couple of DLLs that are listed in the Windows registry, and when you type in your password on a Windows system and Windows tells you, oh, that's not good enough, that's way too short, or it's not complex enough, that's actually a password filter telling you that. So Windows sends that plaintext password to all those DLLs that are listed there, and the DLLs tell Windows, oh, that's an okay password, or I don't like it, ask the user for another one. So it's actually a pretty nice place for a backdoor as well. You can create your own password filter and place it there and intercept plaintext passwords when users change their password. But anyway, I decided to reverse engineer this one, debug it, disassemble it, to see what it actually does. And as it turns out, this password filter, this particular one, always tells Windows, well, that's a great password, I love it, use that one. So it doesn't actually check the password, but in the background, it stores it using that reversible encryption. And when you enable that, you'll see in Active Directory there's a new binary blob there for each user that you enable this on. And it's called user parameters. And as I said, it looks pretty binary, but you see a couple of text strings in there. One of those is gradius chap, and the other one is gradius chap key. If you find this in your Active Directory, that user parameters one, it doesn't mean that there's reversible encryption there. It's stored for other things, such as terminal server profiles are partially stored in there. But if you find those two in there, then yeah, that's reversible encryption. And it also creates a global LSA secret. And what an LSA secret is, it's a way for Windows to store secrets, basically a Windows API. And if you're a programmer, you can tell Windows, hey, I want to store this secret, and I'll give it this name. You don't give it a password or anything. Just give it the name and the secret, and Windows stores that for you in a secure place. And if you know the name of the secret, and you're a domain administrator on the system where the secret is stored, you can retrieve that secret. And there are a couple of tools out there to list those secrets. Kane does it, for example, Kane Enable. LSA dump is another famous one. But when you run those on a system that has this on the domain controller, you'll notice this one is missing. It's not there. You see the DLL creating it, and you see the DLL grabbing it afterwards, but it's not there. So this is a global LSA secret, and that's the major difference. The normal LSA secrets are stored in the registry. Windows stores them there. But this one is stored in Active Directory. And the global part means it's synchronized between domain controllers. So if you have two domain controllers in your domain, and the first domain controller creates this secret, it will be synchronized automatically to the other one. How does this reversible encryption actually work? What Windows does is it takes a 16-byte random, which it generates on the spot, so it's different every time. It takes that LSA secret, which is like 256 bytes. It takes some static key that's hard-coded in the DLL, and it uses that to create a key. And combining those things, it creates that key and encrypts the password using RC4, a Unicode version of the password. And looking back at those things that are stored in Active Directory, the first one, gradius chap, that's actually the encrypted password. That's where Windows stores the result of that procedure. gradius chap key is that 16-byte random, and that's stored with the password. Because in order to decrypt it, you need that 16-byte random. And well, Microsoft obviously added that so to ensure that if two people have the same password, they won't have the same encrypted version of the password. So you won't be able to tell if two users have the same password just by looking at the encrypted version. Looking at the encrypted version, you will notice something else. The first one is PWD1 encrypted, second one is PWD12. See a little bit at the end there with PWD12. Because if you carry the password that's one character longer, the encrypted version will be one character longer as well. And it's Unicode, so one character actually takes up 2 bytes in this case. So by looking at those encrypted passwords, you can determine the length of the password. So for PWD1, it's first character, second character, third character, fourth character, and a terminating null byte there. It contains a terminating null byte. So the interesting is, this is actually pretty much public information, those encrypted passwords. They're stored in Active Directory in a place where you can access them with an ordinary user account. So all you need is a normal user account on the domain to access this information, if reversible encryption is enabled, of course. So you could look at those passwords, for example, and try to find short passwords, or look at how long the domain administrator password is. You won't actually be able to decrypt these passwords because that will require that LSA secret. That's the secret component in the mix. So if we need to decrypt that gradius chap, we need to be on the domain controller and we need to be a domain administrator. So you're pretty much in big trouble already here. But for an attacker, it's nice to grab those plain text passwords. First, we need to grab and parse that user parameter structure. Windows does have some API functions on there, but they're not documented at all, and they're somewhat cumbersome to use. So I decided to implement this myself, and it's not that hard. There's some offsets there, and type length value pairs. And the actual secret, it's stored in ASCII hex, so you have to convert that back to binary, but it's not that hard. Then you need to grab and decrypt that LSA secret. So this is the part where you need the domain administrator privileges. You need that LSA secret to decrypt the passwords. And decrypting the LSA secret, that's where that static key comes in. So Windows actually takes that static key and decrypts the LSA secret somehow. It's just to scramble it somehow, I guess. I missed that the first time, so I was looking at why doesn't my passwords recover right, but I missed that step of decrypting the password using the static key. Then you will derive a key from that by just hashing that LSA secret and the 16-byte random. And if you've ever programmed the Windows Crypto API, there's a derive key function that does this all for you. So it's not a very complicated process. And once you get the key, you use RC4 to simply decrypt that password. So the whole process, it's a bit of a hassle to find out, but when you know it, it's not that difficult. So as I mentioned, that LSA secret, it's the only secret here. So if we are domain administrator, or if we can get that LSA secret some other way, this could actually be a convenient backdoor. Because if we steal that LSA secret when we're on the domain controller, the other information is all public. You can grab that just from Active Directory. So if we grab that LSA secret and copy it to our machine, we can do the whole process from our machine, as long as we have that LSA secret. So if the domain administrator changes his password, or you lose access somehow because the domain administrator discovers that an attacker is there, he could have stolen that LSA secret and just look at the encrypted version of the domain administrator password and decrypt it using that secret. So this could be a backdoor without leaving anything on the system. You just steal something and use that to compromise the domain later on. And as I mentioned, it's synchronized between domain controllers. So if the administrator decides to reinstall that one compromised domain controller because he's sure that the attacker hasn't gotten onto the other domain controllers because, well, maybe they were in a closet somewhere, and changes all the passwords, you could still use that LSA secret to regain access to the domain. And well, this is one of the reasons why recovering from a compromised domain is very difficult, because you don't know what an attacker has done and what he has stolen. Attacker could even enable reversible encryption for some interesting users, or even for the entire domain. Would you notice if it's enabled? It's such an obscure feature. So I've implemented that reversible encryption on a tool called RefDom. So what it still does is when you run it, it's on a domain controller with domain administrator privileges. So I haven't implemented that LSA stealing bit, but it's trivial to do. So when you run it on the domain controller, it will basically display all the passwords there that are stored using reversible encryption. So straightforward tool, no command line options, it just shows you all the passwords. And it should be on blog.teusing.net right now. I've scheduled the post to appear now, so I'll check it after the talk, but it should be there. And I didn't put a license there, but it's basically a public domain. It's like 300 lines of code anyway. So if you want to protect yourself from this, don't use reversible encryption. If you do need it, enable it for those users that really need it. So, and you can enable it per user or for the entire domain. So enabling it per user, if you do really, really need it, would make sense. So finally, what to do. And this is basically a list that shows up in a lot of our reports. And I keep reporting this over and over again, so I decided, let's just put it up here and see what happens. Patching and hardening systems, it's an obvious one. Patching, the Windows part is getting easier and easier, but the third-party products, well, that's still pretty difficult. But the server products, you should try to patch those, and also the client ones. And I know it's really, really difficult. So I'm also a fan of hardening systems, actually disabling those unneeded services, unneeded components, and the ones you do need, disable parts of those, run them under not so privileged users, or even disabling version numbers helps a bit. Segmenting the network. I'm surprised at how often I come in, I see networks and they're entirely flat. There's just one big segment and all the servers and all the clients are just in one segment and they can talk freely between each other. So this is where those third-party applications are really nice, because there's no firewalling or anything, and you can just talk at those high ports with on the servers with the vulnerable database applications and such. And well, it's a big playground. When there's actually some segmentation, what you more than often see is that there's no filtering between segments. So there's a nice client segment, and there's a nice server segment, and maybe some other segments, but there's no firewall between them, so they can talk freely as well. So, in my opinion, it's a really good measure to actually do some filtering in there, and whitelisting filtering. So check what actually needs to be going over that pipe and allow that only. And if that's too much of a hassle for you, then at least some filtering of high ports, for example. But I don't think that works in practice. If you really want to do it right, you'll probably also want to create a management segment from where you manage the servers. So not actually managing the systems from your normal workstation, but VPNing to some segment, or actually having a second box on your PC from where you don't visit strange websites, but just do administration. Don't share important passwords. And I say important passwords because, well, I know how many passwords you have and how many you need to remember, and I'm always told it's very hard, and yeah, I know. So at least not the important ones. Don't use your domain administrator password anywhere else, and don't do that thing with the local administrator passwords. Just disable those accounts or use random passwords or something. And also related to that management LAN, don't log in as domain administrator on some random workstation because you need to do something for a user or something, because your token ends up there, and if that thing is compromised or already has a keylogger on it, then you're in big trouble. Scan and monitor the network. I'm a big fan of sometimes vulnerability scanning on networks, but I'm also a bit careful on recommending this because I'm afraid that people will take the first vulnerability scan and put it on maximum and scan the entire network, and that tends to break some stuff. So, but if you're in a maintenance window, for example, and you decide to scan a couple of your servers, it's actually pretty good practice, and you'd be surprised on what you find on there, the strange ports you find, and or what odd ports applications actually open, and may even find some really nice vulnerabilities. And while monitoring obviously is nice as well. If you can, IDS, and if you can't, then at least some sort of log monitoring. Then when you actually know that there's some domain administrator named hacker on your with a hacker username on your systems. And last but not least, don't let me tell you what to do. Every network is different, of course, and you may be in an entirely different situation with different budgets. So I hope these points help you and gave you some things to talk about, to think about, or maybe you've just confirmed that your network is more secure than most networks out there. So, thanks for your attention. If you do have any questions, this is the time.
If anyone has any questions, please queue up at the microphone.
There's a question over there. You can move up to the microphone.
This LSA secret, is that a static secret or has it a lifetime? Is it?
It's basically generated the one time, so it's static for the entire domain. But if you find it on a different domain, it'll be different. And it's 256-bit bytes, so well, brute forcing that is not really an option.
Any other questions?
On your experience on pen testing, how often do you find the LSA and password that can be decrypted?
Sorry, I didn't quite catch that.
When you pen test,
Yeah?
there are domains where you find LSA and you can decrypt all passwords, and there are times that part is desecrated, isn't it?
I'm sorry, I will walk over to you. I can't get close. So when I pen test servers, how often do I actually find?
You do pen testing.
I do pen testing, yes.
There are domains where there is a LSA thing you can find and decrypt all passwords.
Yes.
And there are times you can't because it's desecrated.
Usually you can't indeed, yeah. And how often do I find it? Do I actually find it? Yes. Not a lot of times. Often you'll find there one or two users that have somehow gotten this enabled at some part. But I've seen a couple of domains where this was enabled, but I hadn't created the tool back then, so I couldn't actually decrypt the passwords. I created the tool because I actually found it in the wild and wanted to decrypt it. And there's some other people that I know already did the research as well, but they're not releasing their tools.
Any more questions?
Sorry, regarding the LSA secret, have you found the randomness in generating the secret? For instance, I set up my first domain. Now, how is the secret generated? Have you found the algorithm?
Yes, it basically just uses the Windows random functions. So I think they're pretty secure now. So it should be pretty random.
Okay, and if you compromise the secret, is there any way to change it on my entire forest, or am I in a big trouble?
If you compromise that LSA secret, is there any way to change it? If the domain is compromised, what you should do is start over. But I realize that's trouble. What you can do is create a small program that talks to the LSA API, and you can set that secret to null, and that will destroy it. So if there are any users on the domain that have reversible encryption enabled, they'll need to change their password in order for it to work again. And if you're unlucky and you have a lot of users, what could happen is that a user's password would suddenly decrypt to the first character 2 null bytes. So you would suddenly have an empty, reversibly encrypted password. So what you probably should do is change all the passwords directly after that.
Any more questions?
Okay, thank you for your attention.